Hi, I'm Shuyang from Northeastern University. I'm here to present the paper Tackle Balancing Constraint for Incremental Semi-Supervised Support Vector Learning. Firstly, I'm going to introduce the background of our work. Semi-supervised support vector machine is one of the most popular methods for semi-supervised learning. To avoid the trivial solution of classifying all the unlabeled examples to a same class, balancing constraint is often used with SVVM. Recently, a novel incremental learning algorithm based on the path-following technique was proposed to significantly scale up SVVM. The fundamental principle of IR SVVM is to constantly detect new samples violating the KKT conditions and add these samples into the KKT violating set A, while pushing the samples in A to satisfy the KKT conditions. The process is shown in the figure. However, the dynamic relationship of balancing constraint with previous labeled and unlabeled samples impedes their incremental method for handling BC SVVM. To fill this gap in this work, we propose a new incremental semi-supervised support vector machine learning algorithm with balancing constraint targeted at more realistic classification problems that often arise in SVVM. Our model also has finite convergence guarantee and cheaper computational complexity than the ones of most existing BC SVVM algorithms. The main issue needs to be addressed for designing our algorithm is how to overcome the challenge of dynamic relationships of balancing constraint with previous labeled and unlabeled samples during incremental learning process. Firstly, we introduce a new Lagrangian multiplier corresponding to the balancing constraint to the original optimization problem of IR SVVM, and sample 0 is a special sample generated from the balancing constraint. We define a virtual balancing dataset V and classify sample 0 into set V separately. Our IRBC SVVM algorithm consists of 3 steps. We have already introduced the algorithm for step 2 earlier, so we only focus on step 1 and step 3 specifically. In step 1, in order to eliminate the original balancing constraint imposed on the original dataset, we apply the incremental learning method in this step to decrease the Lagrangian multiplier of a 0 of the balancing constraint to 0. The process can be seen in this figure. In step 3, to apply the balancing constraint to SVVM, we add the balancing dataset V into the new emerged dataset using the incremental learning method. The process can be seen in this figure. About the experiments. These figures of the average running time are an excellent proof that our model is much faster than the other 2 algorithms. That is because the other 2 algorithms need to rebuild the solution of SVVM from scratch, while our model can directly update the solution of BC SVVM to converge to a local minimal and effectively handle the balancing constraint. This figure presents the unlabeled accuracy of these 3 algorithms. These results demonstrate that by using incremental learning methods to handle balancing constraint, our model is much faster than most existing batch and incremental learning algorithms while retaining the same high classification accuracy as BC SVVM. That's all, thank you.